Greetings, this is Artie from Artifact Electronics. Tonight's guest is this device called an FC Twin, and I think what that stands for is Famicom Twin. It is an early emulator for Nintendo games. This will support both original and Super NES games, as evidenced by two slots. The original game goes in here, and the Super NES games go in here. Not at the same time, of course. It does have a switch on here to select 8-bit and 16-bit, which stands for original and Super NES, respectively. And I guess this is perfectly legal. They sold over 1 million units of this. It came out in 2006. I guess they kept a close watch on copyright. And I guess copyright started to expire around that time. And they reverse engineered this, or just stole some technical manuals. But the hardware in here is completely of their own design. There's nothing really in here, or there shouldn't be anything in here that even resembles the original, because there are more powerful processors in here. There are two processors, one for each type of cartridge, and they're running emulation. That was probably open source emulation, slightly modified to run in here. This game came from a swap meet. It was a guy hawking his wares and running around the center aisle and not letting anybody through, telling him that everything in his stall was half off. The only problem with that was that none of the items that he was selling had any price tags on them. So anyway, I got this for the princely sum of $5. I knew what it was. I think he knew too, but since it came without controllers and without a power supply or anything, he let it go. And I thought it would be real interesting to have a backup that would play NES games and Super NES games. So let's see what this does. It does have a problem because I have, it did come with an RCA cable set, but I found a power supply with the proper specs, plugged it in, have the TV next to it, and the issue is that the power switch basically goes to 16-bit and 8-bit, and I think the corresponding LED is supposed to light up, but nothing lights up. Neither the 16 nor the 8. It is hooked up, and not a peep out of the TV. So let's tear this down, see what's inside, and also let me clean this up a little bit. It is rather filthy. So a few screws later, the innards are revealed. Actually, the thing wasn't as filthy as it looked. The front plate is just worn. I mean, the fake chrome, all of these things won't come off here. That's just, I guess the guy did have it cleaned up before he put it up for sale. But here's the inside. 3-segment board connected by flexible inner board connectors. A potted module over here. Some RAM. And the other stuff is all house marked, so they're probably proprietary graphics chips, processors, whatever. So there's actually quite a bit of stuff in here, I would say. Here are voltage regulators on the heatsink, and I've already spotted something interesting, and that is this cap. It's leaked, and it also looks like the plastic wrapping on it is melted. So I don't think it just leaked, because there's no leakage underneath, but What I'm guessing is they probably shoved the wrong polarity power supply in here, and that's probably directly connected to this cap. And as you well know, electrolytic caps do not like to be reverse biased. That probably made it blow up. That still wouldn't explain why the whole thing doesn't work, unless of course this thing is shorted. But in order to find that out, I've already removed the inner screws too. You can take out this. See if we can see that cap a little better. That's what it looks like. You can see the melted wrapping on it. And yeah, it doesn't look like it leaked, so I think, yeah, and looking at the back of the board, the traces seem to show that the power input, that this cap is directly on the power input rails before the power switch. So maybe that's what caused it to blow up. Let's take it out and see if it's shorted or open, or still works perfectly. Well, let's see what the tester thinks this is. Hello? It's taken quite some time. We got the tester confused. Oh, okay, so it thinks, yeah, from the blue terminal, 3 is the blue terminal, 1 is the red terminal. It thinks it's looking at a diode that has, with a capacitance of 0 picofarads. Well, something's definitely wrong with this. If it sees it as a diode, that could be causing problems. But with that item removed, let's see if power gets to the regulators. There are 2 regulators in here, and if the regulators also got blown out. Alright, so what we got here is there's a 7805 regulator over here, and so let's plug in power and see if power is getting to the regulator and what's coming out of the other end. So, without slipping, here's the input. Ooh, looks like it's... Wait a minute. Maybe I have to flip the power switch. Okay, first position on the power switch. Yeah, so I got to figure out, it looks like there is no power getting here. Let's try the other position on the switch. Maybe it's a bad switch. Oh, okay. We are now getting input voltage. And no output voltage. And how about this guy? Nothing. Let's try the other power switch position for that regulator. Oh, that's interesting. This regulator comes up in the middle position and outputs nothing. Now we changed power switch. So now this regulator isn't getting anything and consequently not outputting anything. But this one is getting input but not putting out anything. Okay then, let's do one final check on these, and that is, let's take out power. And measure from ground to input. And we get a short from ground to output. How about this one? Nope. So now we go back to the center position on the power switch. See if that affects the apparent ground short any. No, this thing's still shorted. And this thing isn't. Alright. Time to take out the regulator and hope that it's the regulator that's shorted and not something on the board. Alright, I had to pull out this heatsink here because I could not remove the regulators. Here's the first one that showed a short on the output. So, fingers crossed. Is the short on the board or on the regulator? So here's the output, and it's not shorted. Alright, that regulator's toast. Here's the second regulator, and we won't even have to measure this one. Where is it? See that crater in there? This thing just blew up. So obviously this one's bad too. And this is also 7805. You can see part of the writing on it. And the interesting thing that I found out is, so why are there two 7805s in here? And it turns out that the way this thing is set up is there are two circuits, two separately powered circuits in here, and the way they switch between the different set of components is they have two regulators, and when they want to go to 8-bit they turn on one of the regulators, and when they go to 16-bit they turn on the other regulator through the switch on the back of here. Interesting approach, but since this is Chinese made, I'm sure that that was the cheapest way to achieve this. So we have two bad regulators. Let's put in new regulators, put the heatsink back on, and see if we can get anything to happen now. Alright, heatsink and two new regulators are in. So now what we can do is, well, before hooking it up completely, let's do the light test, or the LED test. See how it has the two LEDs on it. Oh, that's not going to work because the switch is underneath. So, let's plug in power. So now power is off. Position 1, 16-bit lights up. Position 2, 8-bit lights up. Well, whatever was ailing its power, looks like that got fixed. So now we got to put things back together and give it the real acid test. Let me go ahead and replace this capacitor and put a new one in here and clean up a little bit first. Then we'll put it back in the case and see if we've succeeded. Okay, I fit the board back in. One interesting point to note was I did replace both of these caps, the one that was blown up and the one next to it, which looked okay. But the board had labeled them, was labeled and said these are 47 microfarad at 25 volts. But the intact capacitor I pulled out clearly says, come on, focus. It won't focus. Anyway, the one that was intact that I pulled out, clearly says 220 at 25 volts. So in this case, I did replace it, both of them with 220s, because obviously somebody decided that a 47 wasn't big enough to smooth the input voltage properly. So we got everything replaced. Let's put some of the screws back, because the screws are what hold down these cartridge connectors, and also make sure that we can plug something into the outputs, and then see if we can actually play a game. We saw them not do anything at all. So let's see now if it's all well again. Alright then, let's make the necessary connections. Video, audio. This actually has stereo output, but the TV doesn't. So we'll just have to make do with mono. DC input. Now in order to play anything on here, it uses Super NES controllers like this, and you play either type of game with those controllers. Kind of loosey-goosey, but well. Okay, so let's start off with an original NES game, and we need to go to 8-bit. All right. Okay, I don't want to compete, I want to practice. Not exactly sure what I'm doing wrong here. Oh, that's a... Okay. Okay, goofy foot. All right. I fell into the trash can. Well, there you go. So, original games obviously do work. So now let's see if we have the same luck with Super NES. Remember that there are two separate circuits that both got new voltage regulators. 16-bit. Well, this one also seems to be working. Alright. Let's go to Barrel Cannon Canyon. Ouch. Well, it looks like things are working, both on the regular and the Super NES. So, of course, you know, I'm forced to test this with lots more cartridges to make sure that it really is in good shape, but initial tests seem to show us that our repair was successful. Now, one interesting other test I want to run with this is I have a Super NES cartridge that was used by repair centers to, I guess, after repairs and stuff like that, to burn in the system. And that would probably require a high degree of compatibility. Okay, so how compatible is it? Well, it boots up, which is a good thing. Gives you all the different tests you can run. Controller test, I don't think that's really necessary because we just played a game. The controllers seem to be working fine. So, what is the burn-in test? Is that going to run? Yeah, it seems to run. So this is the cartridge that I think they used, that repair stations used once they had repaired something. Passes everything. And just, I guess, let this run overnight. No, I don't think so, because, you know, there were a lot of Super Nintendos out there, and I don't think they could have possibly run every single one they repaired overnight to test it. But if it runs this is kind of like the reference. If it runs this, that means this thing is pretty compatible. So here's the parts we replaced. For under $10, we ended up with a device that plays both original and Super NES games. I'm sure there's some games that are incompatible because games that weren't done by Nintendo, they did the same thing on Atari computers. They didn't follow instructions. They kind of figured out, oh, I can write to this register and save 3 instructions or whatever, and it would work, for instance, on an Atari 800, but then you would run the game on an Atari 800 XL and the game would fail because you didn't do things the way that were prescribed. You did illegal things, you used registers that just so happened to do what you wanted them to do on one machine, but that didn't do it on the next machine. And it's probably the same with this, that if anybody did not stick exactly to the specs and use registers or timing that wasn't really meant for the original SNES to work, then those games won't work on here either. But from what I read is there's probably like 85 to 90% compatibility of this thing with all of the NES games. So thanks, I hope you enjoyed watching it, and you'll be picking up your own Nintendo FC Twin or whatever for cheap at a swap meet or what. Take it apart and see that it has the common problem, which usually is the power supply. So a thumbs up would be appreciated. Subscribe to see lots of other good stuff. And leave me a comment about what you think, whether it was worth repairing this or not. I'm curious. Take it easy, and I'll be spending the rest of the night playing Donkey Kong. See you later.